All right, so let me give you hex. It should be noted that in some languages, hex has like a delimiter, which is basically just a like tag on it. So normally I'd write like numbers sub 16, right? And y, we'll talk about y16 in a second. Normally this is what I'd write. In some languages, there's like use an O and then this is actually a 0, and then an X, and then you'll type the number in hex, and that'll say, this thing just kind of warns the computer like, yo dude, this following is a hex number, right? In other systems, it's a OH. So this one's in C and derivative languages, and this is in a TI calculator, which is funny. So if you want to do hex stuff in a TI calculator, you can use that. There's a bunch of other delimiters that exist. If you go look at the Wikipedia page for hex, there's, gosh, I think a list of 20 or 30 different delimiters and languages in which those are used. Cool? All right. Basic idea is I should have a number, right, that I might represent with, and I'm going to forget the decimal points today, but you could do this with decimals. So I'd have 16 to the 0 power is my 1 spot, right? And then this should be 16 to the first powers here, and 16 to the second powers here. And this should come up with an obvious problem right away.
You need more symbols.
Why do you need more symbols? Why can't you just write...
You got 0 to 9.
Yeah, but why can't you just write like 3, 10, 15?
Because 10 takes up two digit spaces, right?
Basically because you can't, if you put like commas or something, maybe you could do this, right? And it would be fine.
That's dumb.
But it's probably not a good idea, right? Because if you lose those kind of splices between the places, you'd be confused. Okay, see that? So one fix for this would be to do 0, 3, right? And then each chunk of the number would be 2 spots long. Okay, see that? That would be kind of doable but dumb. So instead of doing this, we've come up with this system where we go, all right, instead we're going to use 0 through 9, right? Like, why reinvent that particular wheel? You may as well use the ones you know. And then also, I don't know, I need a thing for 10 that's not 10, right? So somebody was lazy and they were just like, oh dude, let's just call it A. This is stories like, well, we could make a base 27 system if we just use the alphabet, right? Why's that 27, not 26?
Well, would it be 37 if you add on all the alphabet?
Yeah, we could add on some numbers. So how many letters do I need is the question. Because A is 10, right?
Right.
Then I need a letter for 11 and 12 and how do I know where to stop? Let's see, so I've got
14.
10, 11,
15.
12, 13, 14, 15.
No.
Stop.
Stop, why?
0.
Because we're in base 16 and 15 is 16 minus 1.
Yeah, so this next spot, right, doesn't belong in the spot you would try to write it in. You guys see that? Like G has no place in here because G just means one of these. You guys with me on that? Kind of, sort of, maybe?
Yeah.
Okay, cool. So, for instance, if I had B5, 6, base 16. Oh, and there's another thing here. There's not really a standard convention whether you do lowercase letters or uppercase letters.
Well, there is base 62 apparently, which does that.
Gross. Let's never talk about base 62 ever again. Why would you do that? I don't know. There must be a reason.
It's numbers, all the lowercase, all the uppercase.
Oh, that's horrible. Let's never talk about that ever again. As far as this one goes, hex doesn't have a standard. So you can do either lowercase or uppercase. It depends on the language that you're in or the community you're a part of. Right? Mostly you guys will probably use this for web colors. And for web colors, I think you use uppercase letters by convention. So let me follow that convention.
Back in the days of MySpace, program that's themselves.
Exactly. Okay, anyway. This base 16, can I convert?
Yeah.
How do you convert back to base 10?
It would be
6 times 1 plus 5 times 16.
Okay, so you got 6 times 16 to the 0 plus 5 times 16 to the 1 plus. Yeah, so I need to go to my key, right? Which makes hex a little inconvenient for the first day, right? Because I still have to have this kind of key somewhere. After you get used to it, it gets better. But for right now, it's a little inconvenient. So I got 11 times 16 squared. Oh crap, I'm going to have to figure out what 16 squared is. Okay, so these numbers are all base 10 now, right?
Yeah. 256.
So I have 6 ones and 80, and 11 times 256 is a lot.
2816.
Okay, and all of this junk is base 10, right? And so then you do this addition problem base 10.
2,910.
Okay, pretty good. Okay, shall we do the y for this? Oh, P.S. The addition and multiplication things for hex work in the reasonable ways. You guys want to? I shouldn't skip those. So let's add something at the very least. Multiplying is weird. Okay, so let me add my number B56 plus
FFF.
7FF. That'll be weird. Okay, so now I have to figure out F plus 6 is 21. You jerks. You can't just convert back to...
No, it's 5 carry the 1.
Yeah, so 6 is 5 more, or sorry, so 6 plus F is 6 more than F, right? You start at F and go up 6 spots, you get to 5,
Carry the 16.
and you carry the 1, right?
So 4 carry.
Then you get
5.
4 with a 1, and 1 more is 5, carry the 1. Oh, that was really dumb. 1 plus 5 is 6, plus F is 5, carry the 1. I just did that problem, right? And then I got, let's see, 1 more than B is C, and then 7 more than C is C, D, E, F, 0, 1, 2, 3. Sorry. 7 more than C. 1, 2, 3, 4, 5, 6, 7. It's 3. Carry the 1. You guys with me on that? This bit that I did down here, what was that the equivalent of?
Number line.
Kind of. It was the equivalent of trying to count on my fingers, right? But I don't have 16 fingers. So I basically wrote down, right, the way addition, or the number line, kind of, right? I wrote down fingers to play with. You guys cool with this? Okay. And this number here is,
Base 16.
yeah, this number here is base 16. Yeah, I did this addition base 16, and so the result should be base 16.
And it just so happened that it didn't require
Yeah, and this is why you want to make those marks, right? Because if you're telling somebody, yeah, dude, when you add those two numbers, you get 1355, right? 1355 what? Like, are you base 10? Are you hex? Like, how do I know? And the reason I know that I'm hex is that I was carrying 16s earlier, right? I was carrying the 1 from a hex addition. So that meant a 16.
So we just ended up with all numbers in that, but it could also include the letters.
Yeah, so this certainly could include a letter. Do you want to see one that includes a letter?
Sure.
We can do another one. Oh, and of course I just erased the things I probably need.
Oh, right.
Nah, that's stuff. Okay, so let me pick two numbers that are kind of reasonable. Let me pick A7 plus C4.
Bingo.
And keep in mind, right, the fact that I did a letter and then a number and a letter and then a number has no bearing at all on what these are as like actual quantities, right? That let me add something so that it is clear that that's not always the case, right? They can certainly have any arrangement of letter and number. Those are all available.
You just did that because you needed the 7-4 added above 10.
Yeah. So the way I constructed this example was I thought to myself, I need two numbers that add to more than 9, right? But don't go over 15.
So 7 plus 4 is B.
So 7 plus 4 is B, which if you worked in hex a lot, you would know, right? You would just make these tables a part of your existence. So I got B, why didn't I carry anything?
You didn't hit 16 yet.
Because I didn't hit 16 in that add problem. So here I have A plus C is
7. Well, 7 and then carry 1.
So that means 22.
okay. So if I do A plus C, right? These are 16. If I think to myself base 10, right? This is 10 base 10 plus C is 12.
13.
Oh, B's 11, so C's 12.
Perfect. So I got 22, right? Base 10,
So now subtract.
which is a 16 plus a 6.
Yeah, it's off by 1. So it's 6.
No worries. So I got a 6, carry the 1. And then 1 plus 6 is
7.
still 7. So you got 76B. Which is a terrible way to say this number. Right? You should really say 76B. And for this number over here, you shouldn't say 1355 like I did. You should say 1355.
760B.
Yeah, don't do that, because this is not 700,
Oh.
right? 700 is literally a base 10 number. That's how your design, that's how your brain says things. So just say digits in order.
Can you say like 7 bytes is 6B?
You could maybe do something like that. Bytes, though, are
255,
8.
0 to 255, which 7 is 256.
Yeah, so what you could do is you could do 7 256s and 6 16s and B1s, right? But at that point, you're just converting.
Yeah.
It's 256, right? Doesn't mean anything base 16, or it means something, but it doesn't mean the same thing. Right? So you're kind of doing an implicit conversion. So if I was reading this number, I would say 76B base 16, or 76B in hex. That's good with us?